This video is about the differentiation of inverse trigonometric functions. Let me give you the formulas for differentiation first. So here you have the 6 formulas for differentiation of inverse trigonometric functions. So D17 is for the derivative of arc sine of u, or it's for the inverse sine of u. You can also write arc sine of u as in this form. Okay, so I chose to use the notation arc sine so that you'll not be confused with this, okay, superscript -1. Okay, so it's not the same as an exponent. So that's the inverse function for sine. So if you'll notice, you only need to memorize 3 formulas for this one, because the derivative of arc cosine of u is just the negative of the derivative of arc sine of u. And for arc tangent of u and arc cotangent of u, okay, one of them is just the negative of the other. And then for the derivative of arc secant of u and arc cosecant of u, again, one of them is just the negative of the other. So all in all, you just have to memorize 3 formulas here. So just remember one of them is the negative of the other. So sine and cosine are partners, tangent, cotangent partners, secant and cosecant are partners here in this set of formulas. So let's have an example. First one, you're given a function y equals arctangent of 1/2 of x squared. Okay, again, so you just have to write your function in any of these 6 forms on the left side. So this is in the form arctangent of u, where u is equal to 1/2 of x squared. Okay, so let's get dy over dx. Alright, dy over dx is equal to, so according to our formula D19, it's du, that's the derivative of 1/2 of x squared, over the square root of, it's over 1 plus u squared. Sorry about that, u squared, so 1/2 of x squared squared. Okay, so what we can do here is just differentiate the numerator, which is 1/2 of x squared, using power rule. So you'll have 1/2 as a constant, just copy that, and then take the derivative of x squared with respect to x using power rule, which is just 2x. So over 1 plus 1/2 plus x squared squared is 1/4 x to the 4th. Okay, now simplify the answer. In the numerator, you have 2 over 2, which is just x when simplified. And then 1/4 x to the 4th in the denominator. So that's x over 1 plus 1/4 x to the 4th. Okay, now simplifying the denominator, I don't want the complex fraction in the final answer. Taking the LCD, that is 4. Okay, so you'll have 4 plus x to the 4th in the denominator. Now, let's continue. dy over dx is equal to x times, now, how do you divide fractions again? You get the reciprocal of the denominator and proceed to multiplication with the numerator. So taking the reciprocal of the denominator, you get 4 over 4 plus x squared. So now dy over dx, when simplified, is equal to 4x over 4 plus x squared. This is the derivative of the function. Alright, example number 2, y equals 2 times arc cosine of square root of x. So this is in the form 2 times arc cosine of u, where u is equal to square root of x. Alright, so we have y prime. So we'll be using formula D18. So in this function, we have a constant 2. We can just copy that and then take the derivative of arc cosine of u. So that's negative of du, so that's the derivative of square root of x over square root of 1 minus u squared, so that's square root of x squared. Right? So what is the derivative of square root of x? That is the derivative of x raised to 1/2. So using power rule, we'll have 1/2 x raised to negative 1/2, or that's 1 over 2 square root of x in simplified radical form. Okay, so going back to y prime is equal to negative 2 times the derivative of square root of x is 1 over 2 square root of x over the square root of 1 minus the square root of x squared is just x when simplified. So simplifying our answer, 2 over 2 is 1. So what we'll have is y prime equals negative of 1 over square root of x over square root of 1 minus x. Okay, simplifying our final answer. Simplifying this complex fraction, we'll have 1 over square root of x times square root of 1 minus x. Now, writing x and 1 minus x under one square root symbol, we'll have negative 1 over the square root of x times 1 minus x. Okay, if you want to remove the grouping symbols inside the radical sign, then we'll have negative 1 over square root of x minus x squared. This is the derivative of the function. Now, example number 3 is a power of arc sine of 3x to the 5th. So you can also write this as arc sine of 3x to the 5th raised to the 4th power. So we'll be using the general power rule to differentiate this, where u in that power rule is equal to the base arc sine of 3x to the 5th. So we'll have y prime using power rule, that's 4 times the arc sine of 3x to the 5th raised to 3 times du, okay, where u is arc sine of 3x to the 5th. Alright, so now to differentiate arc sine to the 5th, we'll use d17, where u in this case is 3x to the 5th power. Alright, so we'll have y prime equals 4 times arc sine of 3x to the 5th cubed. So I'll write 3 here. And that derivative of arc sine of u is equal to du. So that's the derivative of 3x to the 5th over the square root of 1 minus u squared, 3x to the 5th squared. Okay, now we'll just get the derivative of 3x to the 5th using power rule. So that's y prime equals 4 arc sine cubed of 3x to the 5th times the derivative of 3x to the 5th is 15x to the 4th over square root of 1 minus 3x to the 5th squared is 9x raised to 10. Okay, we'll just have to simplify our answer. Alright, so 15 times 4, these constants, we have to multiply. 15 times 4, so we'll have y prime equals 15 times 4, which is 60 x to the 4th, then arc sine of 3x to the 5th cubed over the square root of 1 minus 9x squared, or 9x to the 10th power. This is the derivative of the function. Example number 4 is a product of 1 plus x squared and arctangent of x. So to differentiate y with respect to x, we'll use the product rule, where in the product rule, this is u and this is v. Okay, so we'll get y prime using the product rule. That is 1 plus x squared times dv, where dv can be obtained using formula d19. So that's dx. So u here is equal to x. This is u. So dx over 1 plus x squared. Right? Plus. Now take note that first that we are differentiating with respect to x. So this is dx with respect to x. Okay? So plus arctangent of x times the derivative of 1 plus x squared with respect to x also. So that's going to give us 2x. Okay, so dx over dx, or the derivative of x with respect to x, is just 1. So what we have here is 1 plus x squared times this is 1 over 1 plus x squared plus 2x arctangent of x. Alright, so 1 plus x, look at the first term, 1 plus x squared is divided by itself, so we just get the 1. So in the final answer, we get y prime equals 1 plus 2x arctangent of x. This is the derivative of the function. Alright, this is example number 5. So we have two terms on the right side to differentiate with respect to x. In the first term on the right side, we have the form arcsecant of u, where u is equal to x over 2. And in the second term, we have arc cosecant of u, where u is also equal to x over 2. Alright, so y prime is equal to arcsecant using the formula d21, so that's du, derivative of x over 2 with respect to x, over u, x over 2, square root of x over 2 squared minus 1. Okay, and then minus, that is equal to, using d22, negative of derivative of x over 2 over x over 2 times the square root of x over 2 squared minus 1. So let's take the derivative of x over 2 first. And that's it. We can also write this as 1/2 of x. Okay, and then when we copy the constant 1/2, the derivative of x with respect to x is just 1. So the derivative of x over 2 when is just equal to 1/2. Alright, so going back to y prime, so the numerator is 1/2 over x over 2, square root of x over 2 squared minus 1 is just square root of x squared over 4 minus 1. So minus negative, so plus in the second term. Derivative of the numerator is again 1/2 over x over 2, square root of x squared over 4 minus 1. Alright, so simplifying the denominator, the radicand, I mean, y prime is 1/2 of x over 2, taking the LCD in the radicand. LCD is 4, so we'll get x to the 4th minus, no, x squared only, not x to the 4th, x squared minus 1. So plus 1/2 over x over 2, square root of, we do the same thing, take the LCD in the radicand, 4, sorry, this is 4 already. This is 4 in the radicand, x squared minus 4. So this is also x squared minus 4 over 4. Alright, so now simplifying, we have here 1/2 in the numerator and then 1/2 again in the denominator, so we can just cancel this out. Okay, when we simplify, so we'll get y prime equals just 1 in the numerator over x now, square root of x squared minus 4 over 4 plus 1 over x square root of x squared minus 4 over 4. But we can take the square root of 1/4 in the denominator, so we can write our answer. Y prime equals 1 over x over 2. This 2 now here comes from the square root of 4 in the denominator in the radicand. Alright, so now in the radicand, what remains is x squared minus 4. So that's plus 1 over, we do the same thing on the other side, on the other term, x over 2, square root of x squared minus 4. Alright, simplifying our final answer. Now these two, both of these numbers, 2 in the denominator will go to the numerator as we simplify our complex fraction. Okay, so now y prime is equal to 2 over x square root of x squared minus 4 plus 2 over x square root of x squared minus 4. So 2 over square root of x squared minus 4 plus itself will give us 4 over x squared of x squared minus 4. So this is the derivative of the function. The function in number 6 is a quotient of arc cotangent of x and x. Okay, so we'll use quotient rule to differentiate this, where u is equal to the numerator arc cotangent of x and v is equal to the denominator x. Okay, we get y prime using quotient rule. So that's x times the derivative of arc cotangent of x. So that is negative using d20 du. So where u is where v here is x, so the derivative of x with respect to x is 1 over 1 plus u squared, where u here is x, okay, squared. All right, minus the numerator u are cotangent of x times the derivative of v with respect to x, which is 1 all over x squared. Okay, so we'll simplify. We'll get a negative x over 1 plus x squared minus arc cotangent of x. Okay, all over x squared. Now this is again a complex fraction, taking the LCD. In the numerator, that is 1 plus x squared. Okay, so the first term is still the same, negative x minus, that's 1 plus x squared times arc cotangent of x. Alright, so now simplifying our complex fraction, the denominator will be the product of x and 1 plus x squared. Alright, and then the numerator is negative x minus 1 plus x squared, arc cotangent of x. If you want, we can just factor out negative 1 from the numerator, so we can write our final answer in the form negative of x plus 1 plus x squared, arc cotangent of x, all over x times 1 plus x squared. This is the derivative of the function. One last example for the derivative of inverse trigonometric functions. Y prime here will be the derivative of the first term minus the derivative of arc sine of x over a. So for the first term, we'll have to use the quotient rule. So if we are differentiating with respect to x, then a here, we take a here as a constant. So a squared is also a constant. So quotient rule. So we can write our function as x over a squared minus x squared raised to 1/2 minus arc sine of x over a. Okay, so quotient rule for the first term, where u is the numerator and v is the denominator. All right, so it's a squared minus x squared raised to 1/2. That's v times du. Derivative of x with respect to x is 1 minus x times dv, where dv can be obtained using the general power rule, that is 1/2 of a squared minus x squared raised to negative 1/2 times the derivative of the base. The derivative of a squared minus x squared with respect to x is negative 2x. So all over the denominator squared. So a squared minus x squared raised to 1/2 squared is just a squared minus x squared. Okay, minus the derivative of arc sine of u. This is u in the formula. So that is the derivative of u du, remember a is a constant, over square root of 1 minus u squared. Okay, so we'll just differentiate x over a with respect to x. So that is just 1 over a. Okay, this derivative of x over a, you can also write x over a as 1 over a times x. So that's just a is a constant, so just copy 1 over a, and then the derivative of x with respect to x is 1. So derivative of x over a is just 1 over a when simplified. Now going back to y prime, simplifying our answer, and then taking the derivative of x over a. So that is a squared minus x squared raised to 1/2 minus, now we distribute in the second term in the numerator, we'll distribute x inside. Okay, or just multiply multiply x by the expression inside the grouping symbols. Okay, so that's x. We'll have x here times x, so that's going to give us x squared, and then 2 over 2 here. Right, so that's, and then minus sign here, so minus negative, so that's going to give us plus for the second term. So we'll have plus x squared times a squared minus x squared raised to negative 1/2. Okay, all over a squared minus x squared. Minus the derivative of x over a is 1 over a over the square root of 1 minus x squared over a squared. Now simplifying further, we'll have, so this will be simplified, and also this. Alright, so y prime is equal to a squared minus x squared raised to 1/2 plus x squared over a squared minus x squared raised to positive 1/2 this time, all over a squared minus x squared minus 1 over a over, well, taking the LCD in the radicand, so that's a squared LCD, so this will be a squared minus x squared. Alright, so simplifying further, taking the LCD over here, taking the LCD, we'll get y prime equals, so the denominator is still a squared minus x squared. Now the LCD between the two terms in the numerator would be a squared minus x squared raised to 1/2. Now a squared minus x squared raised to 1/2 multiplied by this, we'll get just a squared minus x squared, so plus x squared. Okay, so combining like terms here, you'll get 0 for these two terms. Okay, now minus, now this a here will go to the denominator when simplified. And then this square root of a squared will also go out of the radical sign because square root of a squared is just a. Okay, so 1 over a times 1 over a. 1 over a here comes from the square root of a squared inside the radicand. So square root of a squared minus x squared. Alright, simplifying further. Now both of these expressions will go to the denominator. Okay, rewriting our answer, we'll have still a squared in the numerator, and in the denominator we have a squared minus x squared times a squared minus x squared raised to 1/2 minus, now this a over a is equal to 1. So that's 1 over the square root of a squared minus x squared. Now further simplifying, we'll get y prime by taking the LCD. So the LCD is, of course, a squared minus x squared times a squared minus x squared raised to 1/2. Okay? Because square root of x squared is also a squared minus x squared raised to 1/2. Alright, so the first term is still a squared because it still has the same denominator. Minus, now the LCD divided by square root of a squared minus x squared is going to give us a squared minus x squared. Remember, this LCD divided by this, okay, will give us a squared minus x squared times 1. So that's quantity a squared minus x squared. So we'll have a squared minus a squared plus x squared upon removing the grouping symbols over multiplying the denominators, we'll get a squared minus x squared raised to 3/2. Right? So if you want to write that in radical sign, it's up to you. You can also do that. Now subtracting a squared from itself, we'll get 0. So the final answer will give us x squared over a squared minus x squared raised to 3/2. This is the derivative of the function. Now if you want to write your answer in radical form, then it would be y prime equals x squared over a squared minus x squared square root of a squared minus x squared. It's the same thing in another form.